Okay, so before we start sketching, there's some ground rules that we want to go over. First thing is the degree of the polynomial. Plus leading coefficient. Alexi, don't pay him any attention. Okay, so if the degree is even, and the leading coefficient is positive, this determines where our graph starts and where our graph ends. So do you guys remember the quadrants? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if the degree of the polynomial is positive and is even and the leading coefficient is positive, you are going to start your graph in quadrant 2 and you're going to end your graph in quadrant 1. Now let's say the degree of the degree of the polynomial is odd. Oh, sorry. No, let's keep it even. Sorry. Let's say the degree of the polynomial is even, but now the leading coefficient is negative. We are going to start in quadrant 3 and end in quadrant 4. So we did even positive and then we did even negative. Now we're going to do odd positive. So if the degree is odd and the leading coefficient is positive, we are going to start our graph in quadrant 3 and we are going to end our graph in quadrant 1.
It's just like the stuff that was on the SAT, the PSAT, like where you predict.
Mm-hmm.
That alignment.
Okay, and the final one, if the degree is odd and the leading coefficient is negative. We will start in quadrant 2 and we will end in quadrant 4. Okay, I'm going to go into Desmos to show you this. All right, we'll keep it really simple. So the first one was even and positive. Give me a function that's even and positive. Y equals x squared, right? Isn't the leading coefficient 1? And the degree of our polynomial is even. So where did I start? Quadrant 2. Where did I end? Quadrant 1. Okay, this works. I could change it. Let's do 2x to the 4th. Degree is even, leading coefficient positive. Start, end. X plus 7 raised to the 4th power. Oh, that messed me up. Oh, because of the x plus 7. Okay, don't worry about that because that changes our zeros. Don't worry about that. But okay, let's do negative. Ready? Negative x to the 2nd power. So all I did, I still had even, but what have I done to the leading coefficient? Made it negative. Start quadrant 3, end quadrant 4. All right, next one. So we did even positive, even negative. Let's do odd positive, odd negative. So the most basic one is y equals x, a line. Y equals x. Start quadrant 3, end quadrant 1. What if I had x to the 3rd? Start quadrant 3, end quadrant 1. Let's take this and make it negative. Negative x. Start quadrant 2, end quadrant 1. Start quadrant 2, end quadrant 4. Do we get it? All right. So we need to memorize this. You want to memorize all this based on the degree and the leading coefficient, where your graph starts and where your graph ends. There's more. All right, next part of this. So the next part of this, we're going to say, let's get a different color here. So we'll say bounce, cross, disco dancer. Are we ready? So if the function has a single root, it is a cross. Example, x plus 1. So this is our root. X plus 1 equals 0. X equals negative 1. All right, this is a single root because my x is a 1. That's a single root. So what does that mean? It means when I come to draw my 0 at negative 1, I'm going to cross right through it. I cross right through it. Next one. If the function has a double root, it is going to be a bounce. I think I've showed you this before in different capacities. Oops, let me show you what the root would be. So if we got down to example x squared equals 0, that is a double root. Why is this a double root? Because x is only equal to 0, even though I should have how many solutions? 2. X is only equal to 0, even though I should have 2 solutions. This is called a double root. And what happens when you have a double root? We call it a bounce. So you go to that 0, and instead of going straight through it, you hit it and then bounce back up. All right, and the last one is the disco dancer. If the function has a triple root, we call it the disco dancer. And our example would be x cubed equals 0. Right? Why is this a triple root? Because I know I need 3 roots, but the only one I'm getting is 0. So that means that 0 counts how many times? 3 times. We will not go beyond a triple root. We will not go beyond a triple root. So that means you're going to do your little disco dancer through your root. All right, are we ready to try some problems?
Does that mean if the degree is odd, odd has to be a disco dancer or a straight line?
If the degree is odd, okay, no. So the degree, you're going to see, the degree is just identifying where we're starting and where we're ending, but there's going to be so many other parts of it. You'll see. I'll give you an example right now. So here are our sample problems. So for all of these, I want us to sketch. It's not going to be absolutely perfect. It's just a rough estimate of how this might look. So if I have f of x is equal to x to the second times the quantity of x minus 1 times the quantity of x plus 2. The degree of this polynomial is not 2. Why? Why is the degree of this polynomial not 2? Yeah? Good, because when you're choosing the degree of the polynomial, you want to not consider it factored. You want to consider it was all multiplied out. So if this were all multiplied out, you'd have x to the second times x to the first, which gave us x to the third. But then x to the third times x to the first is x to the fourth. So the degree of this polynomial is 4. All right, leading coefficient, positive or negative? Positive, right? So we are even and positive. So if we're even and positive, that means we are going to start in quadrant 2, and where are we ending? Ending in quadrant 1. What's wrong, Antonio?
No, that's good.
You thought it was a negative number?
No,
Okay, so this is where our graph is starting. This is where our graph is ending. Now what you want to do is you want to find all the zeros. Now, I gave you a polynomial that was already factored. Had this not been factored, what do you think you would have had to do? Factor it. So now I have x squared times the quantity of x minus 1 times the quantity of x plus 2 equals 0. I'm going to set each factor equal to 0. So we have x squared equals 0, x minus 1 equals 0, x plus 2 is equal to 0. This is when you decide if it's a single root, double root, or triple root. X squared equals 0. Explain to me why this is a double root. Not Ange. Somebody else. Explain to me why this is a double root. Okay. Good. Because the degree of is 2, so we should have 2 answers, but how many do I have? Just 1 when we solve this. So when we get x squared, when we square root both sides, we get x is equal to 0. So this is a double root. I put dr, which tells us this will be a bounce. Right, x minus 1 equals 0. How many people say this is a double root? How many people say this is a single root? How many people say it's a triple root? It is absolutely a single root. We solve it, and we get x is equal to 1, and I'm going to put SR for single root, and that is a cross. All right, x plus 2 equals 0. How many people say single root? How many people say double root? Triple root. Good. It is a single root, so we get x is equal to negative 2. I'm going to say single root SR, and that's another cross. And now we're ready for our sketch. So I'm going to make my graph, and I'm going to plot all of my zeros. So we have 0, we have positive 1, and we have negative 2. So now remember, based on what we figured out from the beginning, we are starting our graph here and we're ending our graph here. Since we are starting in quadrant 2, do we all agree we're going to hit the negative 2, 0 first? Right. I'm going to hit the negative 2, 0. So I'm going to see that is a cross. So I'm going to come from up top. I'm going to go through it. I'm going to cross through. I'm not bouncing back up. So we start at the top. We're going to go straight through it. And then just pause for a second. Now, we're ending here. So now I have to work my way through my other zeros. So if I'm ending in quadrant 1, that means I'm hitting the 0, 0 next. So now the 0, 0, that was a bounce. So right now I'm heading down. In order to hit the 0, don't I have to turn my graph? When you turn your graph, you're not going to make it into a V. When you turn your graph, you want it to be like a nice smooth loop. If you do it a V, that's like more like an absolute value. You don't want to do that. You want to do a nice small curve, a nice smooth curve. So I'm going to smooth curve it, and then I'm going to hit the 0. But when I hit that 0, isn't it a bounce? What does that mean when it's a bounce? I'm going to hit it and then bounce back. I'm not crossing it. So I hit that 0, I bounce back down, and then what do I have to do again after I bounce back down? I have to curve it back up. And then the last zero I'm going to hit is x equals positive 1. Is that a cross or is that a bounce? It's a cross. So I'm going to smooth curve it and cross. It does not matter how long you make these curves. It doesn't matter. All right, we ready for the next one? What's the degree of this polynomial? Good. So our degree is 4. And what is the leading coefficient, positive or negative? Positive. So we are even and positive once again. How come this time I took the first exponent and said that was the leading coefficient, but that first sketch I said we couldn't do that? Alexi?
So the first one, it wasn't fully factored.
Fully multiplied. Good, yes. Because for the first one, it wasn't our full polynomial. It was factored. Where this one is our full polynomial, it is not factored. So we are even positive. Do we agree? That means we start and end quadrant 2, end quadrant 1. What do you think I'm going to tell you to do with this polynomial? We're going to have to factor. So I noticed we could pull out a 2x squared. So I'm going to do that. And once I pull out a 2x squared, I'm left with x squared plus 4x plus 2x minus 15. And then I can factor x squared plus 2x minus 15. We're going to have an x plus 5 and x minus 3. Once it's fully factored, we now find our zeros. So we said each factor equal to 0. All right, 2x squared equals 0. What is this? Single root, double root, triple root? Double root. This is a double root at what? X equals 0. So that is a bounce. X plus 5 equals 0. Single root, double root, triple root? Single root. We're going to have x equals negative 5 is a single root. That is a cross. And then last 3, x equals 3 is a single root. That is also a cross. So we come to sketch this. Okay, so we're starting quadrant 2, we're ending quadrant 1. So the first one we're going to hit is negative 5. So I'm going to come from top, I'm going to hit negative 5, I'm going to go straight through. But what happens now? I have to turn to hit that 0. That 0 is a bounce, so I'm going to bounce back down. Oops, I forgot my last 0. What was the last 0? Positive 3. So I'm going to come back down and then cross through it again. Okay, how am I doing on time? Let's do this next one. F of x is equal to 2x times the quantity of x plus 4 cubed times the quantity of x minus 1. So we always need to first figure out the degree and the sign of the leading coefficient. So how am I going to figure out the degree here? Ange? Good. Do we all agree in this parenthesis it would end up being x cubed is our leading degree there? So then we have an x times an x cubed is x to the 4th times another x is x to the 5th. So our degree is 5. The leading coefficient, what is our leading coefficient? Positive or negative? Positive. So we are odd and positive. If we are odd and positive, what does that mean for us? We start in quadrant 3 and we end in quadrant 1. It is already factored for us, which is great. Because it's already factored for us, I can now just go into finding my zeros. All right, 2x equals 0. This is a single root. Oh, sorry, this is x equals 0 first. X equals 0. This is a single root, so it is a cross. What about the quantity of x plus 4 cubed? What is that going to be? This is going to be a triple root. I'm going to say TR. And once we know it's a triple root, we know it's a disco dancer. Then what we do is we just take the x plus 4, set it equal to 0, and get x equals negative 4. So we're going to have a disco dancer at x equals negative 4. And the last one, x equals positive 1, will be a single root, and it will cross. All right, let's sketch. So we said we are starting in quadrant 3 and we are ending in quadrant 1. 1, 2, 3. 1, 2, 3, 4. Okay, so what do we have? We have negative 4, we have 0, and then positive 1. The first one, since we're starting in quadrant 3, the first one we are going to hit is the disco dancer. So what does that mean? I'm starting here, and then the disco dancer is a little bit hard. I usually draw the curve through it first. And then I need to turn to hit that 0. When I hit that 0, is it a bounce or a cross? It is a cross. So I cross it. Then I turn again to hit the last 0. And that last 0, is it a bounce or a cross? A cross. And there we are. Do we know what time flex starts? Everybody know? What happened? No? Nobody knows? All right, let's just do one more. I only have one more I want to show you anyway. I haven't showed you a negative one. Okay, perfect. What number is this? 4? Okay, so do we agree this is even and negative? If we're even and negative, that means we are starting in quadrant 2 and we are ending in starting in quadrant 3 and ending in quadrant 4. Now we need to factor. In order to factor, I'm going to pull out that negative. So we have x squared plus 5x minus 24 equals 0. I'm going to keep that GCF of negative out. So we're going to have an x plus 8 and x minus 3. And now we solve. Will negative 1 ever equal 0, that GCF? No. So that means nothing to us. Next one, we have x plus 8 equals 0 at x equals negative 8. That's a single root, which is a cross. And then x minus 3 equals 0 at x equals 3. Again, that is a single root, which is a cross. Are we ready? Let's sketch. Okay, so remember, we are starting in quadrant 3. So I'm starting here and I'm ending here. So that means I'm going to come from the bottom. I'm going to cross. And then we're going to go all the way to our other 0. And we're going to cross. So it looks something like this. Okay, we are done for today.